This is part 2 of the tool room training series, how to navigate and tweak the data. We're going to review the cost overrides, delete a part and start fresh, manual overrides, drill into the numbers, review some geometric cost drivers, create a scenario, and then create a cost comparison report. Once again, we're going to begin in the a priori desktop. And this time, instead of going to a CAD file and opening it, we're going to open a file that's already been costed in a priori. We do that by hitting the magnifying glass. What I can then do is type in part of the name of the string of the file and the part will come up. Or I can say I want to look for all assemblies or roll-ups or stock machine components, and I can sort that database. So we're going to open up the base plate part. This is going to come up right where we left off. Here we can see we've got our part summary. And there's been quite a bit of work done here as far as adding secondaries, all of that. If you're interested in seeing what someone else had done on the part, you can go to Edit and look at the cost override summary. Here we can see that we've added optional processes. We've selected a parallel surface chain for wire. We overrode the diameter of the wire. We changed the surface finish on the surfaces to 0.4, and then we included a bunch of surfaces for hard milling. If you want to clear this all out and start fresh, you hit Clear Cost Overrides. It will get rid of everything. Or if you really screw up a part and you want to change things, you can go in and delete a component and then go delete out that base component and start all over with a clean slate. But for now, let's say we like what we got. What we'd like to do then is go in and drill into some of the numbers. If I go to the Part Details tab, again it's always left mouse, then I want to go to Table View and view all data. What comes up is the current and the last saved. If I made a change, you'd get a previous cost in there as well. There's lots of high-level data up here. If I were to, for example, hit the plus this way, it's going to show me the total amortized batch cost on here. If I hit the minus, it brings it back down. Or I could start drilling down. If I hit this plus, it says what was included in stock machining. You get the price and the total cycle time. Then we had a surface treatment in there of a degrease and an x-ray inspection, 43 seconds for each one of those. What we're interested in is stock machining, so I'll hit the plus on that and then begin drilling down. You have the material cost, we have the machining. Total machine time was 2 hours and 46 minutes, and that's going to include the 3-axis mill, the heat treat, the hard mill, the wire EDM, and the grinder. And then these are the cycle times for each one of those that we had calculated. If I drill into the 3-axis mill, it's going to give me very specific details. 37 minutes, 13 minutes of roughing, 17 minutes of surface finishing. And then I can go down even further and I get more details like the range. It was from 96 meters per minute to 186 meters per minute surface footage. I can tweak those in other spots. It says in setup 1 we had 1,800 seconds, and in setup 2 we had 414. If you come down here into the 3-axis mill and hit the plus, those are the two setups. If I pick this one, it shows me the orientation of the setup, and then if I right click and hit highlight associated GCDs, it shows me everything that was done in that setup, and then I hit setup 2, once again highlight associated GCDs, it will show me all of those details. If somebody, for example, doesn't like the number that we've calculated for any one of these, anywhere you see a pen, you can override it. So if you think that the heat treat is actually going to take 2 minutes instead of 36 seconds, I could go in and put 120 seconds in there. So what you've seen me do is go in and actually hard code in 2 minutes for the heat treat value. What I can also do is override some of the variables that go into calculating the value. So I'll go ahead and select this surface and then edit the operation on the surface. What we see is it's side milled at 58 seconds. What a priori does is first it landed on a 3-axis mill, then it determines the most appropriate way to make that item. In this case, it considered face cut, undercut, face corner pick. It landed on side milling. Once it lands on side milling, then what it has to do is determine a few things. It needs to know what the number of passes is. It chooses a tool diameter based on the surface that it's machining. It has a surface footage or millimeter or meters per minute based on the material and the cutting tool. In addition, it's going to look at chip load, number of flutes on the tool, requested feet per tooth. If you wish and you know this surface requires more passes, let's say you want 5 passes on that surface, you could go in and override any one of these values and then recalculate the cost. You can override the surface footage, you can override the chip load, you can do it for any item in here. You can override the tool diameter. You could also do that in bulk. I don't recommend making these changes, but if you want to, you can. So now a priori has come back from costing, and what we could see is the cycle time went up to 291 seconds because we increased the cycle time. So I've changed the numbers here in a couple of different ways. One last thing we can do is if you want to change the numbers at a high level. So for example, you want to just override the material cost. You can do it in the materials database by changing cost per pound, or you could just say that for this part, I'm going to pay $100 for material. The way you do that is you go to this cost override button. When I click that, these little boxes open up. I can then come over here and say I paid $100 for material for this part. Once again, it's another way that you could do an override. So this has come back. We're at $184 now, and you could see that this has been changed. You've got $100 up here, and it's pretty obvious where the changes are. Once again, all those changes will be displayed for you in the cost override summary. So if you want to go see them, you can go look and see what those are and clear them all if you'd like. Next, what we'll do is take a look at the geometric cost drivers. These are what enable us to quickly get to a cost based on the geometry that we see. Once again, I'm going to hover over this area and hit the minus. That'll collapse this down. The geometric cost drivers are going to be unique from process group to process group. So stock machining has a unique set, sheet metal has a unique set, and so sheet metal would have a flat pattern, bends, angles of bends, forms. Stock machining is going to have setup axes, cross section, pockets, slots, things like that. So if we take a look at the base properties, we just pull base information about the model. We pull a cross section to determine the stock size. We look at setup axis candidates and the IJK vectors on those, and then we're going to land on the most appropriate set. That's where these will be chosen from. So these are actually hard setups. These are just setup axis candidates. If we drop down further, stock trim represents the bounding box of the material. And then we've got perimeters, which are just outlines here, which can be leveraged for water jetting out the part, different things like that. Pockets represent volumes that need to be machined away. If we scroll over to the right, we have all the attributes of those pockets listed here, and then the cycle time and the tool and all of that information that was calculated for each one of those. Then we also have slots. These are just areas that could potentially be slot milled, but once again, we've got rough milling, slot milling for those. We choose the appropriate tool, the removal rates. And then finally, if we drop down a little further, you've got holes. In this case, there are 15 simple holes in here. These can all be used as sort tabs. So if I want to sort by diameter, I want to sort by process that the hole was made with. So in this case, I've got center drill, I got center drill peck counter stink, center drill. We can scroll over to the right. You can see each of those and drill into the details. If there were cosmetic threads on those holes, you'd automatically get taps. Here you can see the cycle times as well. If I change the tolerance on the hole, I can drive a reamer also. And then finally, the surfaces, which represent the planar faces, curve walls, and curved surfaces. Here it's saying that there's 66 planar faces. We can sort by finished area from largest to smallest, most expensive to least expensive to machine on the resultant time. This is going to show you the technique that was selected for each one of these surfaces. Some of the stuff we got chamfer mills on. Again, these are the small surfaces on the top that actually get chamfer milled. And then we calculate the cycle time for each one of those things. So when all this stuff is combined, we get a nice roughing and finishing cycle time. So the last thing we'll do is with a priori, you can look at alternatives. So maybe I want to make this part out of a different material. Currently, I've got a hot worked steel. So I can go to scenarios, save this as a new scenario, and let's call it SS for stainless steel. It'll take this one, push it over, and you'll see a new version of this right there. There's the base plate. I'm going to go ahead and save that. When there's a little asterisk right here, that means that the part hasn't been saved. That will go away now. That's going to be the one that's stored in the database. And then I'm going to come over here. This is just a copy of that. What we're going to do is change the material to a stainless steel. And then go ahead and cost that. So now a priori is going to go through and run this as if it were stainless. The other things we can do is change the annual volume, change the region of the world that we're doing it, change the different coatings. Anything that you've seen me change, we can save it and put it into one of these and create a scenario. And then you can do cost comparison reports of multiple scenarios. So a priori's now come back from costing. If we go to the cost summary, we can look in here. You've got red arrows indicating that the cost has gone up. I've gone from 184 to 207. We had locked that material in, so that was hard-coded. It doesn't matter what we chose for material, but all the other things continue to change. If the cost went down, you'd have green arrows indicating that the cost went down. I'm going to go ahead and save this, and then what I'm going to do is a cost comparison report. So we'll do File, New, Cost Comparison, give that a name, and then it's going to bring up a blank report, and I'm going to add components with the string of base in the name. What it'll do is grab those two parts. There's the initial, and there's the scenario SS, and add those in. Those things are now dropped into the sheet, and we see the part and the percent difference from part to part. This also can be exported to a report.